this first one, simple, straightforward conversion. You take your base of t, your power of 3, your index of 4, and so you're done. You just need to convert it into that form. If you're writing this or entering this online, you would write t to the power of 3 over 4. For the second example, a little bit more complicated because your base is in the denominator, but we're just going to take our base of x. The power is 2, but in the denominator means it's a negative 2. Divide by our index of 5. So that would be our rational exponent form. Entering it online, 2 to the power of parentheses negative 2/5 would be the way that you would enter that. Okay, C, again continuing this pattern, if we take our base of 6 or our base of x to the power of 6 divided by our index of 2, what does 3 over 2 reduce to? 6 over 2, I'm sorry, reduces to 3. Okay. Now, what if I told you that's not complete? You'd only get partial credit for that. What's missing? Yeah, was the original index an even number? Square root. Original index is even, so you do have to test for absolute values. So could x even be a negative in the original? Yeah, because to an even power becomes positive. So we do need to test what happens if x is negative. Cube it. That does not guarantee non-negative, so you do need absolute values around it to simplify your answer. Okay, then finally, the one thing I want to point out with this, in this section on the conversions, okay, is the index greater than the power? So it doesn't fit the conditions for simplified radicals. We're not looking to simplify them here. All we're looking to do is convert the form. So we take our base, power, index, leave it just like that. You don't need to simplify it at all. I leave it just in that improper fraction as the rational power. All right, for the conversion into radicals, we have our base of y, so that goes into our radical. Our power of 1, our index of 7. And now again, don't write any 1s for your powers, and just like don't write any 2s for your index. And if you were entering this online, the way that you would enter this would be the 7th root, and you just spell the word, 7th RT, put whatever's inside the radical in parentheses or grouping symbols. The next one, it's the same idea. You don't have to simplify your radical. You just need to take your radical base of x to the power of 3, index of 2. So even though the simplified form is x, square root of x, you don't need to write that. Just leave it in this form is fine for the converting. In the next one, again, we have our negative. The negative is going to move our base, which is a radical, into the denominator. Base t, power 3, index 2. Put the 1 in the numerator to make it a fraction. And then finally d, in this example, again, a negative power moves our radical to the denominator with our base b, power of 1, so I don't need to write anything. Index of 2, so I don't need to write anything. Just put my 1 there to make it a fraction. All right, so all that's kind of leading up to these last two problems are the ones that you need to make sure that you can do by hand. And they both revolve around a couple things. You can solve them each two different ways. If you notice 4 and 27, those are both perfect powers. So one way to solve these is to think of them in terms of their exponential form. So 4 is 2 squared. 2 squared to the 5 halves, you now apply the properties of exponents. Power to a power, you do what with their powers? Power to a power, you multiply. So 2 times 5 halves, the 2 and the half cancel, leaving 2 to the 5th. If you wanted to extend that out or multiply that out to get 32, that's small enough that you could do that, and that's fine. Okay, for the second problem, 27 is also a perfect power. It's 3 cubed to the negative 2/3. So again, what we can do here, take a power to a power. The 3's cancel. We get 3 to the minus 2. The negative moves our base into the denominator, changes the sign of its power to positive. 3 squared is 9. So you get 1 over 9 as your simplified form. And then if you go back, the other way to approach these instead of rational powers is to think of them in terms of, or in the exponential form, is to think of them in terms of radicals. So we could have also looked at this as converting it into a radical with a base of 4, power of 5, index of 2, which is square root. And then apply the property that it doesn't matter whether you apply your power first or your radical first. So if I applied the radical first, the square root of 4 is 2. 2 to the 5th is 32. I could do the same thing with this 27. If I converted this into radical form first, so the negative power moves my radical to the denominator. 27 is my base, my power is 2, my index is 3. And so now, in looking at this, I can apply my radical first. The cube root of 27, all squared. The cube root of 27 is 3. 3 squared gives me my 9, so 1 over 9 becomes my fraction. And so I don't care which method you choose, whatever seems to work for you or is most convenient.